Dart skill presents gradient of line. The slope or the gradient of a straight line on the xy coordinate plane is a measure of its steepness. Imagine climbing up a hill. As the hill becomes steeper and steeper, we say the slope or the gradient of the hill becomes larger and larger. For a straight line in the xy coordinate plane, the slope is defined as the ratio of the increase in y coordinates to that in x coordinates between any 2 points on the straight line. So if you have the x and the y axis, here's the x and here's the y axis. Think of a straight line or a line segment and pick any 2 points on that line segment. Let's say the coordinates of this point is x1 comma y1 and the coordinates of this point is x2 comma y2. And if you go ahead and complete the right triangle over here, so this is a right angle, meaning this side is parallel to the y-axis and this side is parallel to the x-axis. The slope is defined as the increase in y, also called the vertical increase, vertical increase, and it's also got a name. It's also called the rise. So it's rising. Increase in y means it's rising. Divided by, so it's a ratio, and the top number is the increase in y or the vertical increase or the rise between any 2 points on the straight line over the increase in x, also called the horizontal increase, or the run. So the slope is rise over run or the vertical increase over the horizontal increase, and that is equal to, for these 2 points, the increase in the y value between these 2 points is y2, the y value of this point, y2, minus the y value of this point, which is y1, over the ratio. It's a ratio of the increase in the y coordinates. So this is y2 minus y1 to that means the increase in x coordinates. Now if you look at this point and this point, the x coordinates, just like the y coordinates, let me just go ahead and draw a dotted line so that you could understand the increase. So if you think about the increase in the x coordinates between these 2 points, this is a x2 and this is a x1. So this is going to be a x2 minus x1, just like it was a y2 over here for this point and a y1 over here. Reason why we had a y2 minus y1 on the top. So this is x2 minus x1. So given the coordinates of 2 points on a straight line, you can find the slope or the gradient of the straight line by using this formula. A few questions to answer though. What is the slope of a straight line that goes the other way? Like this. Now if you pick any 2 points on the straight line, doesn't matter which 2 points, I'm going to pick this one and let's say this one. And if I imagine this to be a hill and this is where I'm standing going this way, I can see that as x increases, so I'm moving in the positive x direction, the value of y decreases. So when this increases, this decreases. And when this increases, when y increases, I'm moving in the negative x direction, which means x is decreasing. Therefore, the slope of this straight line is negative. Slope is negative. What's the slope of a straight line that is parallel to the x-axis? Hey, this is not even a hill, this is a plain land, therefore the slope is 0. And if you want to apply the slope formula, you'll see that if you pick any 2 points, no matter again which 2 points you pick, the y values of 2 points on any straight line that's parallel to the x-axis is always the same. Therefore, y2 minus y1, the numerator of this fraction, becomes equal to 0. So no matter which x's you pick, whatever x2 minus x1 is, this is always going to be 0. So the slope is 0. Now, what happens to the slope of a straight line that is parallel to the y-axis this time? Something that goes like this. Either this side or even the y-axis, doesn't matter. Now if you want to apply this formula out here, the problem is between any 2 points on this straight line that is running parallel to the y-axis, the x coordinates are the same. Therefore, essentially, the denominator of this fraction becomes equal to 0. So the slope is not defined. Slope is undefined. You want to note that the slope of parallel lines are equal and the slope of perpendicular lines are negative reciprocals of each other. Now, I guess the first one is pretty simple to follow. When you have two lines that are parallel, they have to have the same slope. Now, let me talk about a little on the second one. So, if you have a straight line whose slope is, let's say, m1, and then there's another straight line that's perpendicular to that straight line that has got a slope of m1, the slope of the other straight line is going to be the negative reciprocal, so negative 1 over m1. So that if you multiply the two slopes, you get negative 1. Time for some problems. Find the slope of a straight line that passes through the points negative 4, 1 and 8, negative 5. So we are just going to apply the slope formula that says that slope is equal to y2 minus y1 over x2 minus x1. Slope is also called the gradient. And so if you think about the first point as x1 y1 and the second one is x2 y2. So y2 is negative 5. Let's just plug in the numbers. y2 is negative 5 minus y1 minus y1 is 1 over x2 is 8 minus x1 is negative 4. So minus negative 4. So this is going to be equal to negative 6 on the top and 8 minus negative 4. This minus negative turns the 4 to a positive. So we have an 8 plus 4 which is 12. Therefore the slope is negative 1/2. If you reduce this 6 over 12, you get 1/2. Let's do another one. Find the slope of a straight line that is parallel to and perpendicular to the straight line passing through the points 1, 2 and 5, 8. So we need to find two slopes. One that is parallel to the straight line passing through these 2 points and one for a line that is perpendicular to the straight line passing through these 2 points. And to be able to do that, we first need to find the slope of the straight line containing these 2 points. So the slope of that straight line is going to be y2 minus y1 over x2 minus x1, which is equal to 8 minus 2 over 5 minus 1, which is equal to 6 on the top, 5 minus 1 is 4 on the bottom. If you simplify that, you get a 3 over 2, 3/2 or 1.5. So this is the slope of this straight line. For a parallel line, the slope is exactly the same. So you have slope is equal to 3 over 2. And for a perpendicular line, it's the negative reciprocal of this slope. So it's going to be slope is equal to, for the perpendicular line, negative, what's the reciprocal of 3 over 2? The reciprocal of a fraction is obtained by flipping over the numerator and the denominator. So this is going to be negative 2/3. That's the slope. Let's try another one. Determine if the 3 points A, B and C lie on the same straight line. Now when 3 points lie on the same straight line, the slope, as you can see, is always going to be the same. The slope of a straight line is fixed. So if we can prove that the slope between these 2 points is the same as the slope between these 2 points, we can say that the 3 points are on the same straight line, also called collinear. That's another term used to indicate that the points are on the same straight line. So the slope between A and B, let's write slope with a subscript AB, is equal to y2. So this is going to be 2 minus, y2 is 2 minus 1 over x2 is 0 minus negative 5. So this is 1 over 5, 1/5. Let's try and find the slope between B and C. Slope of BC is going to be y2 12 minus 2 y1 over x2 is 2 minus x1 is 0. So this is going to be equal to 10 over 2, which is 5. And 1/5 is not the same as 5. Therefore, the slope between these 2 points is not the same as the slope between these 2 points, which means the 3 points cannot be on the same straight line. So the answer is a big no.